Hello students, welcome back to my YouTube channel Siddu Mathematics. Today we will be revising all the formulas of class 10 in this one video. These formulas are very important formulas for your examinations. You can also follow and support me through Insta and Facebook. In the previous classes, we have already revised theorems of circles and formulas of surface areas and volumes. In this video, we will be learning all the formulas. Okay, let us start with the first chapter, that is real numbers. In this chapter there are two major formulas. First one is A is equal to BQ plus R. This formula is also known as Euclid's division algorithm. This formula is used to find the HCF, that is highest common factor. In this formula, that is A is equal to BQ plus R, A and B are positive integers. Whereas Q is quotient and R is remainder, where R is greater than or equal to 0 and less than B. Once again, what is the formula? A is equal to BQ plus R. This is also known as Euclid's division algorithm. This formula is used to find the HCF, that is nothing but highest common factor, where A and B are positive integers. Q is the quotient, R is the remainder. R must be greater than or equal to 0 or less than B. Okay, now let us go to the second formula, that is LCM into HCF is equal to product of two numbers. In this formula, there are three quantities: LCM, HCF and product of two numbers. In examinations, we will be given any two quantities and we will be asked to find the third one. For example, if they give LCM and product of two numbers, then they will ask us to find the HCF. If they give HCF and product of two numbers, then they will ask us to find the LCM. If they give LCM and HCF, they will ask us to find the product of two numbers. In this way, these types of questions will be asked from chapter 1, that is real numbers. Now let us go to the second chapter, that is polynomials. In this chapter, there are three types. Let us discuss one by one. First one is linear polynomial. General form of linear polynomial is ax plus b. Now let me discuss about this polynomial. Here a and b are constants and x is variable. Since the power of the x is 1, therefore degree of the polynomial is 1. Degree of the polynomial means the highest power of the variable in this polynomial. Number of zeros or solutions or roots is 1, and the graph of linear polynomial is always straight line and it crosses the x-axis once. Now second comes the quadratic polynomial. General form of quadratic polynomial is ax square plus bx plus c. This is quadratic polynomial. In this, a, b and c are constants, where x is variable, and the degree of the polynomial is 2. In this polynomial, 2 is the degree of polynomial. Number of zeros or solutions or roots are 2. Quadratic polynomial has two types of graphs, type 1 and type 2. Let me discuss. Type 1 is possible only when in ax square plus bx plus c, when a is greater than 0, and type 2 is possible when in ax square plus bx plus c a is less than 0. These types of shapes are called parabola. These types of graphs are possible only in quadratic polynomials, and in quadratic polynomials, curves will cross the x-axis twice. That is, these are the curves, they are crossing the x-axis. This is y-axis, this is x-axis. This is y-axis, this is x-axis. These curves both are crossing the x-axis twice. Parabola of type 1 of type 1, that is this one. Parabola of type 1 is known as parabola open upwards. That is, this parabola is open upwards. And parabola of type 2, that is this one, is known as parabola open downwards. That is, this is the type 2 parabola, it is open in the downwards. Therefore, this type 2 is known as parabola open downwards. Third one is cubic polynomial. General form of cubic polynomial is ax cube plus bx square plus cx plus d. Here a, b, c and d are constants, where x is variable. Here degree of the polynomial is 3. This is the degree of the polynomial. Number of zeros or solutions or roots are 3. And for example, this is the graph. In cubic polynomial, curve crosses the x-axis thrice. That is 1, 2 and 3. Next comes the relation between zeros and coefficient. First for quadratic. Let alpha and beta be the two zeros of quadratic polynomial ax square plus bx plus c. Here what they have given? They have given two zeros. One is alpha and one is beta of quadratic polynomial ax square plus bx plus c. Now we have to define the relation between zeros and coefficient. That is defined as sum of zeros, that is alpha plus beta, is equal to minus b by a. Alpha plus beta is equal to minus b divided by a. Next, product of zeros. That is alpha into beta is equal to c by a. Product of zeros, alpha into beta, that is equal to c divided by a. Now let us define the relation for cubic polynomial. Since we know that for cubic polynomial there will be three zeros, let alpha, beta and gamma be the zeros of cubic polynomial ax cube plus bx square plus cx plus d. Since this is cubic polynomial, there are three zeros, alpha, beta and gamma. Let us define the relation between zeros and coefficient. Sum of zeros, that is alpha plus beta plus gamma, is equal to minus b by a. Sum of zeros taking product of two at a time. It means alpha into beta plus beta into gamma plus alpha into gamma. Listen carefully. Sum of zeros. Yes, we are doing sum. Next, taking product of two. We are taking product of two. It means sum of zeros taking product of two at a time. Sum of zeros taking product of two at a time. That is equal to c by a. Next comes the product of zeros. That is alpha into beta into gamma is equal to minus d divided by sum of zeros taking product of two at a time and product of zeros. These are the relation between zeros and coefficient for quadratic and cubic polynomial. Next comes the division algorithm. that is dividend is equal to divisor into quotient plus remainder. This is the division algorithm. Dividend is equal to divisor into quotient plus remainder. This can be easily explained like this. This is dividend. This is divisor. This is quotient. This is remainder. Listen carefully. Dividend is equal to divisor into quotient plus remainder. Let us jump to the third chapter, that is pair of linear equations in two variables. As we know that linear equation in two variables will be in the form of ax plus by plus c is equal to 0. This is the linear equation in two variables. Here a, b and c are constants and x and y are variables. Since this equation has two variables x and y, therefore this is called linear equation in two variables. Now we are given with two equations, a1x plus b1y plus c1 is equal to 0. This is equation 1, and another equation a2x plus b2y plus c2 is equal to 0. This is equation 2. Now let us define the relations. If a1 by a2 is not equal to b1 by b2, then graphically these two lines will intersect at one point, at this point. Therefore, since both the lines are having one point in common, therefore there will be only one solution or unique solution. If a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then two lines overlap on each other, or two lines will be coincident. It means there are many points common. Many points means there are infinite number of points common between both the lines. It means there are infinite number of solutions. If a1 by a2 is equal to b1 by b2 but not equal to c1 by c2, it means both the lines will be parallel to each other graphically. If two lines are parallel to each other, then there are no points in common between the two lines, therefore no solutions. Once again, we are given with the two equations, a1x plus b1y plus c1 equal to 0, and another equation a2x plus b2y plus c2 equal to 0. When we derive the relations, when a1 by a2 is not equal to b1 by b2, then two lines will get intersect and there will be one point in common. If there is one point in common, therefore only one solution will be there. Only one solution is nothing but unique solution. If a1 by a2 is equal to b1 by b2 equal to c1 by c2, then the two lines will coincide. Coincide is nothing but they will overlap on each other. It means there are many points met. Infinite points will be there. Therefore, infinite number of solutions. Next, come to the third one. If a1 by a2 is equal to b1 by b2 but not equal to c1 by c2, it means graphically the two lines will be parallel. Parallel means there are no points in common between these two lines, therefore there will be no solutions. Now let us proceed for the next formula, that is formula for cross multiplication. The formula is as follows: x divided by b1 c2 minus b2 c1, that is equal to y divided by c1 a2 minus c2 a1, that is equal to 1 divided by a1 b2 minus a2 b1. This is the formula for cross multiplication. Even though if you forget this formula, it is easy to form the formula. Let me tell you. Write down b1 b2 c1 c2 a1 a2, again b1 b2. Now according to the arrow marks, cross multiplying in this way, x, y and 1. Now write down the formula: x divided by b1 c2 minus b2 c1, that is equal to y divided by c1 a2 minus c2 a1, that is equal to 1 divided by a1 b2 minus a2 b1. See how easy it is to form the formula. Even though if you forget, it is easy to form the formula. This formula is used to find the values of x and y, that is this x and this y. The next chapter comes chapter 4, that is quadratic equation. As we are very familiar with quadratic polynomial, then it is very easy to understand the quadratic equation. The general form of quadratic equation is as follows: and the degree of the quadratic equation is 2, that is this one. As we have also learned that degree of the quadratic polynomial is 2. Similarly, degree of quadratic equation is also 2. If, listen carefully, if the expression that is ax square plus bx plus c, this is the expression, right? If it contains equal to, then it is equation. The difference between the expression and equation is, if expression contains equal to sign, then it is equation. Okay, now to find the roots of quadratic equation, we use several methods. Some of them are factorization, or splitting middle term. And the next one is completing square method. Or by using quadratic formula. What is quadratic formula? The quadratic formula is as follows. X is equal to minus b plus or minus root of b square minus 4ac divided by 2a. This formula is used to find the roots. Please remember this formula. This formula is very important. This formula has repeated several times in examination. And next comes the formula of discriminant. And is denoted by D. This formula is used to find the nature of the roots. To find the nature of the roots. If b square minus 4ac is greater than 0, then the roots are distinct and real. If b square minus 4ac is equal to 0, then the roots are real and equal. If b square minus 4ac is less than 0, then the roots are not real. Please remember these things. Sometimes these formulas result in confusion. Once again, D is the discriminant. Why this formula is used? This formula is used to find the nature of the roots. If b square minus 4ac is greater than 0, then the roots are distinct and real. If b square minus 4ac is equal to 0, then the roots are real and equal. If b square minus 4ac is less than 0, then the roots are not real. Now let us start with the next chapter, that is arithmetic progression. In this chapter there are two major problems and very important problems. If first term of an AP is A and common difference is D, then nth term is given by an equal to a plus n minus 1 into d. Here an is the nth term, a is the first term, n is the number of terms and d is the common difference. Here nth term an is sometimes also denoted by L, that is last term. We can also write L equal to a plus n minus 1 into d. L is nothing but an, last term or nth term, both are same. Next comes the sum formula. If they are given first term as a, and common difference D. If they ask us to find the sum of all the terms of an AP, then the formula is Sn is equal to, Sn means sum of n terms, is equal to n by 2 into 2a plus n minus 1 into d. Sn means sum of n terms, n means number of terms, a means first term, n number of terms, d means common difference. This formula is used to find the sum of n terms. Sn means sum of n terms, a first term, d common difference, and n is number of terms. As I go on explaining, please note down. This will help you in examination so that even you can revise here only. The above formula that is given, that is Sn equal to n by 2 into 2a plus n minus 1 into d, this formula can be further solved. That is, first write down the formula Sn equal to n by 2 into 2a plus n minus 1 into d. Now I will solve this formula further. This can be written as n by 2 as it is. 2a can be written as a plus a. This 2a can be written as a plus b. Yes, of course, it can be n minus 1 into d. Now listen carefully. Observe things carefully. N by 2 into, listen now. This a plus n minus 1 into d is nothing but an formula. In the place of a plus n minus 1 into d, I can replace this formula an. Now I will replace a plus an. Sometimes this formula, that is the new formula that I am circling, this formula is used when nth term and first term is given. Sometimes you feel that this formula is confusing, but the questions are asked many times.
Thank you students for watching my video. Please like, share and subscribe my YouTube channel. Thank you.